This is a scaffold question, and we have a boy, 40 kilograms here, on a scaffold, and the scaffold does have a mass not listed. We'll label that as 30 kilograms. So let's identify where the forces are acting on this. Now, why don't we make this our point of rotation for force tension 1 spot. We could do the force tension 2, but I just choose the left side since the boy is referenced from the left side. So straight down is his force of gravity acting on this plank. The plank can be considered a lever arm. Okay, and that is 392 newtons. And all of the mass of the plank will look like it comes from a center point, we call the center of gravity. I'll just put a dot there and draw downwards there. Okay, and that would be 294 newtons. Okay, so our job is to find the tension force in the second cable and, of course, the first cable. Since the force tension 1 will be acting on a point of rotation, that will be a distance of 0, so no torque associated with them. So we'll call upon the second condition of static equilibrium. The sum of all torques is equal to 0. Okay, and that's going to equal, let's see, force tension 2. And that distance is 3 meters all the way to the point of rotation. So there's my force upwards, and then 3 meters. So we'll put a 3 next to that. Okay, and now that was a positive torque because that's causing counterclockwise torque. And these two will be negative torques because they're causing clockwise torque. If you think of this as the point of rotation, this is causing it to go downwards, and so is that. So I'll go minus 392 multiplied by the distance of 0.6 right there to my point of rotation. And then minus 294. Now here's the tricky part. We have to remember, since all of the mass looks like it's coming from the center, from the plank, we'll take 3 and divide it by 2. So that would be times 1.5. And then we can find force tension 2's value. And force tension 2 is 225 newtons. Okay, now we can use this value to find force tension 1. We could make this a rotation point and then reverse our signs and redo. Or we could use the first condition of static equilibrium. The sum of all forces must equal 0. We'll choose that because that's a little simpler. We don't need to worry about distances then. So we'll say sum of all forces in the y direction equals 0, equals upwards of force tension 1, so that's positive, plus another one going upwards, which is also positive, so plus 225. And then we'll subtract 392 because it's going downwards, and then subtract 294 since that one is also going downwards. And then we can solve for force tension 1 is 461 newtons. Okay, and again, these will all add and subtract together, but remember, it must go to the other side to get our answer. And looking at this, I see a larger value closer to force tension 1 than there is at force tension 2, and it does make sense because the boy is closer to that rotating point.